All right, section 3.4 is the product rule and the quotient rule. Unlike the chain rule, these ones are much more straightforward. They have the same process that you do every single time. What's changing is the functions that you're working with. Okay, so we'll start with the product rule. Now, the product rule comes up when you have two different functions multiplied together. Okay, we know how to deal with them when they're added or subtracted. We can just do them individually. However, when you want to find the derivative of two functions that are multiplied, we have to use this special rule to deal with that. Okay, so say we have one function f and another function g, and we want to find the derivative. Okay, these are multiplied together. The formula says, okay, the product rule says that it's going to be the derivative of the first function times the second function plus the derivative of the second function times the first function. Okay, so it's a little more complicated. You can't just take each derivative separately and multiply the answers together. We have to follow this rule. Okay, although I should say that once you have the rule written down, it's fairly easy to follow along and plug things in because our functions are going to break down into the basics that we've been studying over the past couple weeks. So let's say we have the function e to the 3x times x to the fourth, and we want to find the derivative, y prime. Okay. So the process goes like this. You want to look at your functions and you want to label them f and g. Okay, your first function will be f, your second function will be g. So right below, I'm going to say, okay, my f is my e to the 3x. That's my first function. And my g will be x to the fourth. All right? From there, we want to find each of these individual derivatives. Okay, we know how to find the derivative of e to the 3x. We'll use a basic chain rule. And we know how to find the derivative of x to the fourth. Okay, that's a basic power rule. So here, e to the 3x, we had a shortcut for this when we did our chain rule. And the shortcut said we get the same thing back, e to the 3x, with a multiplier out front. And the multiplier out front was the derivative of the power. The derivative of 3x is just 3. So here we now have our final answer for f prime. And g of x, the derivative of x to the fourth, well, the 4 comes down out front. X, subtract 1 from the power, giving us 4x cubed. Once you have these four pieces, okay, the first two we got right from the problem, we can then plug our answer into the product rule. The product rule says that the derivative of our function, our original problem here, will be f prime times g. This is the first piece. So we find our f prime, which is 3e to the 3x times g, which was x to the fourth, plus the second part of our formula says g prime times f. So we go to our g prime, which is 4x cubed, times f, which was e to the 3x. Okay, so the answer here, if we start with y equals e to the 3x times x to the fourth, and we want to find the derivative, okay, we used our analysis down here, broke it up into littler pieces that we know how to calculate, put it into our formula, and we get 3e to the 3x times x to the fourth plus 4x cubed times e to the 3x. Okay, so the nice thing about the product rule is that they all work the same exact way. You're always going to start with two things multiplied. You'll break it down into an f and a g, find the corresponding derivatives, and then plug it back into the formula. What's going to change, like I mentioned before, is the pieces that you have here. Okay, we'll do some examples of this after the video, and we'll look at some simple ones, and we'll build up to some of the harder ones using more complicated chain rules and things like that as our examples move along into chapter 4. You know, they'll start to get a little bit more difficult, but again, they all break down into these little building blocks, these things that we've studied the basics of. Okay, so that's our product rule. Now we want to talk about the quotient rule. Okay, the product rule came about because we had two things multiplied together and we needed a special formula. The quotient rule is very similar, only now instead of having two things multiplied together, we're going to have one function dividing another function. So if we wanted to find the derivative of f of x over g of x, that's a quotient, okay, one thing over another one. Again, we're going to have a special formula in order to use this. Okay, it's not just the derivative of the top over the derivative of the bottom. It's more complicated than that. And again, as I've mentioned before, if you want to know where these formulas come from, there's some really good stuff at the end of the chapter that shows you, and it works with limits and things that we don't cover in class. Okay, so the formula here is going to be the derivative of the top, f prime, times the bottom, g of x, minus the derivative of the bottom, g prime of x, times the top, which is f of x, all over the bottom squared. Okay? Something I need to point out here that's different from the product rule is that order here is very important. With the product rule, it doesn't really matter which came first or second because everything's multiplied and added. But here, because we have this subtraction sign, you have to make sure that f is your top function, g is your bottom function, and then you plug in accordingly. Okay, so let's look at an example. Let's say we have y equals e to the 5x over x cubed. Okay, this is a quotient. We have one function over another one, and we would like to find the derivative of this function. Okay, so again, the first step is going to be to label our f and our g function. F is always going to be your top function. So my f of x here will be e to the 5x, and my g of x here, which is my bottom function, will be my x cubed. Okay? All I did was label them according to what I started with. Then I want to find each of their corresponding derivatives. So the derivative of e to the 5x, again, we have a shortcut here. We're going to get the same thing back with a multiplier out front. The multiplier out front is the derivative of the power, which would just be a 5. We want to find our g prime of x. Okay? So the derivative of x cubed, the 3 will come down out front. X, subtract 1 from the power. Okay, so we have 3x squared. Now that we have all 4 pieces, we want to very carefully plug this into our formula. So we have in our first piece, f prime times g. So I have f prime, which is 5e to the 5x, times g, which is x cubed, minus, okay, we're subtracting off g prime times f. So g prime is 3x squared times f, which was e to the 5x. And that whole thing is divided by g squared. Okay, so here g is x cubed, and that whole thing squared. Okay, so now we've plugged it all in. There are ways we can simplify this, you know, move things around. We're not going to do that in this example, but we will look at some later where we will want to simplify, etc., etc. So again, and just like the product rule, the quotient rule is nice because they all work the same way. What's going to change are these functions, but doesn't matter, the process is the same. You're going to pick your f and your g, where f is the top function, g is your bottom function, find their corresponding derivatives, and then plug it into the formula. Okay? So that's our basic product rule and quotient rule. We'll try out some examples to make sure we can get used to this, plugging stuff in, and see how we can start with the basics and then build up to more complicated ones where we'll be using the same process but on functions that are a bit harder than the ones we have here.